155 is now kind of summarizing everything we've learned about decimals, and so we're going to do order of operations for sure, but then also it wants to show you the connection between fractions and decimals. So if you have a decimal, we learned how to write it as a fraction, but if you have a fraction, how do you write it as a decimal? Well, just don't forget that this fraction bar is actually division. This is 3 divided by 5, okay? So what are we dividing by? We're dividing by 5, so where does he go? On the outside, and who goes on the inside? The 3. So this is kind of interesting because we've never taken like a smaller number and divided by a bigger number, really. So like, can 5 go into 3? No. But where is 3's decimal point technically right now? Nope. No. Behind it, right? So we can like write it like this. So what we'll do is we'll pull that decimal point straight up, and you just ask yourself, can 5 go into 3? No. But what can we put behind this 3? A 0. And we can put as many zeros as we need to, right? Can 5 go into 30, though? Yeah, how many times? 6. So 3/5, guys, if you put 3 divided by 5 in your calculator, you would get 6/10. All right? So what we're going to do is we're always just going to take that top number, that numerator, he goes in the house, and then our denominator, that's what we're dividing by, okay? So we're going to do the same thing. We're dividing by 20 into 3. What's our sign going to be? It's going to just stay a negative, right? And then again, I'm going to put that that decimal behind him, and I'm just going to add a couple zeros. All right. Can 20 go into 3? No. But can 20 go into 30? How many times? Just once. So you put 20 under your 30 and do the subtraction. What's 30? Take away 20. 10. And then what do I do? Bring down the 0. And then how many times does 20 go into 100? Well, think how many times does 2 go into 10? 5, right? So 5 times 20 is 100. So we went in perfectly. So what is negative 3/20? That's the equivalent of negative 15/100. So that's the decimal equivalent. And like I said, I know you guys don't think this way, but this is really cool that you guys are able to convert these without touching a single calculator. All right, what is 1/3? Well, the 3 is what we're dividing by, and the 1 goes on the inside. But again, since we can't do 3 into 1, we're going to go ahead and put the decimal behind the 1 and bring it straight up and put a couple zeros behind it. Okay? And this is one that you'll notice something kind of weird happening. Can 3 go into 1? Nope. Can 3 go into 10? Yeah, how many times? 3. What's 3 times 3? 9. So what's 10 take away 9? 1. Bring down the 0. You see something happening. Can 3 go into 10? Yep. How many times? 3 times. What's 3 times 3? 9. 10 take away 9 is 0. Or 1. I can't talk. Bring the 0 down. And what are you guys noticing that what would continue to happen over and over again? That would be 10 minus 9, 10 minus 9, 10 minus 9, right? So how do we show this answer? Remember, it's just whatever number the 3 is repeating, just put that over it. Okay, so even though we did like 33, or you might have done 0.333, you just put the bar over the one number that repeats. So the 3 is the only thing that's repeating, so we only have to write the 3 once, and then we put the bar over it. All right, let's go ahead and do this guy. We're dividing by 16, so he'll be on the outside, and 5 will be on the inside. And again, we'll put the decimal behind the 5 and bring it straight up. All right, 16s. We might not be the most familiar with 16s, but you can count by multiples of 16, right? 16 times 1 is 16. 16 times 2, well, it's 16 plus 16, that's 32. And then 16 times 3 is 32 plus 16, or 48. And that's pretty close to 50, right? So 16 times 3 is going to get us to 48. So we'll put 48 right below this. And then what's 50 take away 48? 2. And remember, I can put as many zeros back there as I need to. So I'll bring down the 20, or the 0 to make 20. How many times does 16 go into 20? Just once, right? So we'll put a 1 and then put 16 down there. What's 20 take away 16? 4, right? Bring down a 0. Well, we were just talking about how 16 times 3 is 48, so that's too high, so we want 16 times 2. And 16 times 2 is 32. 40, take away 32, use your fingers, whatever you need to do. That's 8. Bring down the 0. And then what that is going to do, you're like, okay, 16 times 3 was 48. What's 16 times 4? I don't know. What did you say? It is 16 times 5. If you go over here, guys, and do 16 times 5, 5 times 6 is 30. Put your 0, carry your 3. 5 times 1 is 5, plus 3 is 80. We go in perfectly 5 times, okay? So it was a little bit more work, but 5/16 is a terminating decimal. It's 0.3125. All right. Then we're going to get into these fractions. Like, notice this one's an improper fraction. The bigger number's on top, which just means we will have 1 and something or 2 and something ahead of the decimal, okay? Keep in mind our sign is going to be negative, but I'm not really going to worry about it when I'm doing the division. So this is 13 divided by 11. So the 11 will be on the outside and the 13 will be on the inside. And I'll put the decimal point right behind the 13. And you ask yourself, can 11 go into 13? Yeah. So for the first time, we can put a number in front of the decimal. This one kind of goes long, so maybe write small. How many times is 11 times 1? 11. 13 take away 11 is what? 2. Bring down your 0. 11 still only goes into 20 one time, right? What's 11 times 2? It's 22, so that would be too high. So we still only go in one time. So we'll have 11. And then what's 20 take away 11? 9, yep. Bring down the 0, and we have 90. And 11, what's nice about 11 is their multiples are easy. They're the double digits, right? 55, 66, 77, 88, which is really close to 90, right? So what times 11 gets you to 88? 8. So we'll do 88. What's 90 take away 88? 2. What do we do? Bring down the 0. And it starts repeating again. Absolutely. So how many times does 11 go into 20? One time. You put 11 down there, and 9 would be remaining, and then we'd have a 90. So now instead of just one number, like 3 up there was repeating, what numbers are going to repeat for us? 1 and 8, 1 and 8, 1 and 8, 1 and 8. So the final answer is, don't forget it's negative, negative 1.18, and the bar is over the 1 and the 8. You see what I'm talking about? Like, we would have kept going, you get 1, 8, 1, 8, 1, 8. So whatever numbers repeat is like where the bar goes. So since 1 and 8 were repeating, we needed to write both of them with a bar. Since 3 was the only one repeating, we just had to write 3 ones with a bar. All right, this next one is kind of interesting. Notice it already has a number, like a whole number. So our answer is going to be negative 1 and something. So all we really need to do is focus on this. Let's see what decimal 7/8 is, and then we'll put it behind the 1, the negative 1, okay? So what are we dividing by? We're dividing by 8, and we're dividing into 7. Again, the decimal point's behind the 7. I'm going to bring him straight up. Can 8 go into 7? No. So we got to add a 0. Can 8 go into 70? Yes. Think of your times tables. How close to 70 can we get? 8 times. You got it. And that will get us to 64. 70 take away 64 is 6. We'll bring down another 0. Again, you can bring as many zeros down as you need to. 8 times what? How close can we get to 60? 7 times, because 8 times 7 is 56. 60 take away 56 is 4. Bring down a 0. I like this because what do we get? 40. And how many times does 8 go into 40? 5 times, which is nice. So we terminated, okay? So what is our final answer? Well, we have to remember this decimal part was just the 7/8 part. We still have a negative 1 in front of the decimal, okay? So it's negative 1.875. Does that make sense, guys? So just focus on the fraction part. If you wanted to make that an improper fraction, you could. You could make it an improper fraction, and you would get that 1 in front. But to me, we already know it's a 1. Why mess with it? Let's just focus on the fraction part and turn it into a decimal, and then we're good to go. Is that okay, guys? So they're just reminding you that fractions and decimals are interchangeable. They are equivalent. The fraction bar is division. All right, so then the next one is not bad, but then B and C get kind of yucky. So in order to compare decimals and fractions, they either both need to be decimals or both need to be fractions. Personally, I think changing them all to decimals is the easiest, okay? But let's look at A. It is already both in decimals. They're both negative, and then we just go spot by spot, okay? So the first zeros match, the second zeros match, the eighth match, and then you get to the 3 and the 2, right? Normally, if this was a positive number, the 3 would be bigger and we'd want to eat this guy. But since it's negative, a bigger number is worse, right? And so we want to eat this guy. He's not as negative, right? He's not as negative. Being $2 in debt is better than being $3 in debt. Is kind of how I think of it. All right, on B, what we need to do is we need to change 1/2 to decimals. Some of you guys might know what 1/2 is as a decimal. What's 1/2 as a decimal? Does anybody know? It is 0.5, okay? Say you didn't know that, you could do the division, 2 into 1, right? What goes behind the 1? The decimal, bring it straight up. And then what goes behind the decimal? A 0. How many times does 2 go into 10? 5 times. All right, so now we're not really comparing 0.501 to 1/2. We're really comparing 0.501 to 0.5. Is that okay? And again, just compare it place value by place value. The zeros match, the 5s match, and then technically what's behind this 5? A bunch of zeros, right? So what would happen when you got here? That 1 is a little bit bigger than all those zeros. So 0.501 is bigger than 1/2. Is that okay? We're going to do the exact same thing. Let's do our division over here. Let's see what 3/7 is as a decimal. So we're going to take 7 and we're going to divide it into 3, put the decimal behind it, and bring it straight up. Can 7 go into 3? No. So we'll put a 0 there. Can 7 go into 30? Yes. How many times? 4 times. 5 times would be 35. We're going to do 4 times here. All right. So that gives us 28. 30 take away 28 is 2. Bring down a 0. How many times does 7 go into 20? 2 times. Because 3 times would be 21. It'd be a little too high, right? So 2 times 7 is 14. Do your subtraction. 20 take away 14. Use your fingers, whatever you need to do. That's 6. Bring down a 0. How many times does 7 go into 60? 8 times. We did that like over here somewhere, right? 7 times 8 was 56, so we'll put 8. So notice we're matching. Like this whole time I'm doing this, 4, 2, 8, we're matching. So I need to keep going. Like if I got 0.43, I'd be done, right? Because the 3 would have been bigger than the 2 and I wouldn't need to keep going. But so far we're matching 4, 2, 8. This next one, drum roll, will let us decide, okay? So this was 56. 60 take away 56 was 4, bring down a 0. How many times does 7 go into 40? 5 times. And that's all the further we need to go because we now know that this guy's bigger, right? He is equivalent, so we are really comparing 0.428 to 0.4285, right? So who's the bigger guy? Him, right? So we need to put if we're eating him, we're technically eating 3/7. It's hard because you like have to remember to go back to the original, right? So on my math lab, if they asked which one's bigger, technically 3/7 is bigger, even though we needed it in decimal form to know that it was bigger. Is that okay? The next part gets a little tedious as well, because what they want us to do is order it from smallest to largest. And sometimes they'll throw fractions in there, so you need to know what the fraction is as a decimal. Guys, keep in mind what we've already done. Yes, ma'am, sorry.
Whenever we do these, do you want us, whenever we put it in order, do you want us to do the decimal or the...
The original. Okay. And that's because, I'm glad you asked that, because my math, and I tend to do it, like I want to put the decimal, I'm like, oh, that's what I use. And then you'd get a red X on my math lab, because they'll be like, where the heck did 0.3 repeating come from? I didn't give you 0.3 repeating, I gave you 1/3. So kind of keep that in mind. That's a perfect question, Michaela. They are actually wanting us to order these. So even though we have to turn that into a decimal to know how to order it, that's the 1/3 wherever he goes, okay? What I was just going to point out was we already did 1/3 up here, right? And what was 1/3? A bunch of 3s. So what I'm going to do right below 1/3 is I'm just going to write it as a bunch of 3s. Put a handful of 3s down there, right? We already know that. So now what we can do is we can compare place value by place value. So do you guys agree that each of them start with 2 3s? Okay. But you get here, that's a 1, that's a 3, that's a 0. So which one's the smallest? The one with the 0, right? Because notice they're saying smallest to largest, right? So this is the smallest, so this would go in first, 0.330. And then what's the next biggest, 1 or 3? 331. And then this is kind of what Michaela was asking about. What's the largest, the 3 repeating? But did we ever really get a 3 repeating? No. What number was it? 1/3. Is that okay? Guys, is it okay if I skip E? It's doing the same thing. I want to jump over here to F, okay? E is just doing the same thing. You would change 15/7 to a decimal and compare it, okay? Let me give you the answer if you want to do it later, okay? 2.142 is the smallest, and then 15/7 is the middle, and then 2.15 is the largest, okay? I don't feel like we need to do it because we kind of just did it. I kind of want to focus on these because there's 2 things going on here, okay? So on these, what we have to do, and again, I'm kind of running out of room, he's going to stay as is. We know that's 1 point something, so we need to figure out what 21/36 is, okay? So 21 is in that house, and 36 is out here. And we'll put some zeros behind it. Can 36 go into 21? No. Can 36 go into 210? It can. It goes in, I think, 5 times. So I'm going to put this decimal up here. It can't go into 21, but it can go in 5 times. So off somewhere, like I know we don't have a whole lot of room, I'm going to do 36 times 5. 5 times 6 is 30, carry my 3. 5 times 3 is 15, plus 3 is 180. I didn't give us a whole lot of room here. So 210, take away 180 is 30. Bring down a 0. How many times does 36 go into 300? Well, 36 times 10 would be 360, so that's too big. And then 30 less than that, 36 less than that, so 9 would be too big. So it's going to be 8 times. And again, I'm kind of just doing it quick, but you would get there. So let's do 36 times 8 up here. 8 times 6 is 48. Put your 8, carry your 4. 8 times 3 is 24, plus 8 is 28. So we have 288 there. All right. Again, do your fingers, whatever you need to do. 300 take away 88 is 12. Bring down the 0. How many times does 36 go into 120? I'll just kind of tell you real quickly. It's 3 times. So 36 times 3. 3 times 6 is 18. Carry your 1. 3 times 3 is 9, plus 1 is 108. And then you're going to see something happen. Because 120 take away 108 is 12. Bring down the 0. What's going to happen? We get 120 over and over and over again. So what number is going to be repeating? The 3. Okay? So that guy is really 1.583 repeating. So let's write that right below him. 1.583 repeating. All right? Just to save us some time, because I know we don't have a whole lot of room and you're understanding what we're doing, we would do 36 divided into 38. 36 goes into 38 one whole time, so we would get 1 point something. But then you would quickly see that it's the smallest because it's only 1.05 repeating. And you wouldn't even have to go to the 0.5. You could stop at 1.0, right? Because this is 1.5, this is 1.5. So 1.0 would be enough. You could stop there. So what is the right order? Again, go to the originals. 38 over 36. Which one? This one's kind of hard to compare. Which one's smaller? This guy or this guy? The first one, right? Because he stops, right? He doesn't stop. He keeps going on forever. So 1.5833, and then 1 and 21/36. And you guys did it. Again, none of it's hard. It's just kind of tedious because, like, depending on whether they give you 1 fraction or 2, if you're good at keeping track of your work, take advantage of fractions you've already converted. Like 1/3, you know it's 0.3 repeating. Never convert it again, right? We remember that it's that. All right. So on the back it says, now that you know how to convert fractions to decimals, we can kind of keep that in mind as we do order of operations. So on the back, oops, I'm going to leave that because I know she's still writing that. So on the back, what we're going to notice is we're going to have all those things that we've had before in chapter 1, 2, and even 4. PEMDAS. PEMDAS is still following us, okay? So let's write that up here, PEMDAS. So remember with PEMDAS, parentheses are any kind of grouping method. So like this is a grouping method. We would do first. Exponents are second. Multiplication and division are both tied. So whatever one comes first on the left, you would do first. And then addition and subtraction are both tied. They're the last things you'll do. So notice here we have an exponent and we have 0.4. So what do we need to do first? The exponent. So what is 0.3 squared? That's 0.3 times 0.3 minus 0.4. Is that okay? So I still haven't calculated it. I've just shown what it is, right? So on Tuesday, I have to remember what day of the week we're on, right? On Tuesday, we learned how to multiply decimals. So off to the side, I'm going to do my little multiplication. What's 3 times 3? 9. And then how many decimal points do we have? 2. So we'll go 1, 2. So what is 0.3 squared? It's just 0.09 minus 0.4. Is that okay so far? But notice we have a small number. We have 09 take away 0.4. So we have to flip the order, right? So this is actually 0.09 plus negative 0.4. We got to remember all those rules. I said negative, but then I didn't put my negative. So whenever you have a subtraction, you can write it as addition. So what we're actually going to do, again, I'm going to kind of just do it off to the side. I'm going to do 0.4 minus 0.09. 0.4 minus 0.09. And something I want to point out was a lot of people just put 9 there. No, what's technically above the 9? A 0. So we actually have to borrow. A lot of people would put 49 there. I'm like, no, that would be if you're adding. So since we're subtracting, we have to put a 0 and we got to borrow. So our 4 will change to a 3 and our 0 will change to a 10. What's 10 take away 9? 1. And then what's 3 take away 0? 3. Bring the decimal straight down. So our answer is going to be 0.31. Will it be positive or negative? I heard it. Say it louder. Nope. I thought you said negative. It's going to be negative because he was a bigger one, right? 40 cents is more than 9 cents, right? 40 cents is bigger and he was negative, so it's going to be a negative 0.31. All right. B, we can do our shortcuts. Do you guys remember what your shortcut is when you multiply by 100? You just move your decimal to the right, however many zeros there are, right? So 100, we're going to take 7.3 and just move our decimal over 2 spots. 1, 2. So what is that really? 730. And then on multiplying by 10, we'll just move it 1 spot. So what's that become? 72. And I can't do that in my head, so I'll write it down here. What's 730 minus 72? It's just a normal subtraction where we'll have to borrow. So this 3 will become a 2, and this 0 will become a 10. 10 take away 2 is 8. I can't do 2 take away 7, so we'll borrow again. He'll become a 6, and he'll become a 12. 12 take away 7 is 5, and then 6 take away nothing is 6. So our final answer, guys? Nope, because he was just a 7, and I just borrowed from him once. I borrowed from the 3, but I just borrowed from the 7 once, so he's just a 6. So we have 658 is our final answer there. Is that okay? So if you remember that, it's great, because it just kind of saves you from having to actually do the multiplication. On C, the order of operations is this grouping symbol, so we need to do this first and get an answer, and then we'll divide by 2, okay? So how do we line up 4 plus 0.42? Where's 4's decimal? I know. Now you know what it feels like to be a teacher. The 4's decimal is actually right behind it, right? So this is 4.00, and then we'll add 0.42 like that. Right? Think about $4. If you have $4, couldn't you just say 4 like that or $4 like that? Okay? So now we can just add up vertically. So 0 plus 2 is 2. 0 plus 4 is 4. Bring down the decimal. And 4 plus 0 is 4. So what does the top add up to? 4.42. But what do we still need to do? Divide by negative 2. So what's our answer going to be? Positive or negative? Negative. So let's put our negative there. And then let's do our division over here. Who's on the outside of the house? Who's on the inside? The 2's on the outside. I'm not going to worry about the sign, okay? And then 4.42 is on the inside. All right? This one's a nice division because 4, 4, and 2 are all divisible by 2. So we can go pretty quickly through it. 2 goes into 4 twice. Do the subtraction, you get 0. Oh, I forgot to move my decimal point up. Move your decimal point straight up, right? Bring down the 4. How many times does 2 go into 4? Twice. Do the subtraction, and then bring that to 2. How many times does 2 go into 2? Once. So our final answer is negative 2.21. Great job, guys. Again, nothing really new as far as PEMDAS goes. It just gets complicated because they're going to give us crap like this, where we have fractions and decimals going on. But like I said, fractions are hard. Stay away from fractions because in order to add and subtract them, we need common denominators and all that stuff. So what you want to do is you want to do decimal form, okay? So technically this is division minus multiplication. So what we need to do are the multiplication and division first. So let's do the 1 divided by 4. Does anybody know what a quarter is as a decimal? Say it louder. Why'd you know that? Because it's a quarter, right? 1/4 is a quarter. What is a quarter? 0.25. Is that okay if we avoid the division and just put 0.25 there? Is that right? Do you have quarters and dollars? I know that sounds weird, but like, yeah, back home. But here though, are you familiar with, okay, because that was like, I was using quarters for the division, like divide by 25, and I have someone from England, and he's like, we don't have quarters, you know, so I'm like, oh, I just assumed that. But are you okay that a quarter, guys, is 0.25? If not, just do the division and you'll have the answer, okay? Here, let's do the multiplication off to the side. 65 times 3. And I'm not worried about the decimal until the end, right? What's 3 times 5? 15. Carry your 1. What's 3 times 6? 18 plus 1 is 19. Does that look okay? But our original 3 and 6.5 had 1 decimal. So I'm going to move them over. And what do we have? 19.5. Does that look okay? But notice again, we kind of have a small number, a quarter, take away a larger number, 19.5. So I'm going to rewrite this as 0.25 plus negative 19.5. And again, if you don't need to do that and you know that you're just going to be subtracting the two, that's fine. So I'm going to leave room for my answer, but down here I'm just going to do 19.5 minus 0.25. Because whenever you have opposite signs, you subtract, right? What do I need to put behind that first 5? A 0, and then we'll just borrow. Borrow from the 5, he'll become a 4, and this will be a 10. 10 take away 5 is 5. 4 take away 2 is 2. Bring down the decimal point. And then 9 take away nothing is 9. So we get 19.25. But is our answer going to be positive or negative based on these two numbers? Negative. We're going to have negative 19.25. Because the 19.5 was the bigger number and it was negative. Guys, E's identical to this. Do we need to do that? Okay, I don't mean to I don't want to jip you guys, but I feel like you're getting it. So on this one, it's identical. You would do the division of the 3 by 5 and get a decimal. You do the multiplication of the 6.4 times the 3 and get a decimal, and then you could combine them at the end. Okay, I'll tell you the answer just in case you want to do it later, guys. It's 19.8. All right. I do want to do F because there's a little bit more kind of going on. Order of operations, what do we have to do first? The parentheses. So this is really negative 9.1 plus negative 3.3, right? Whenever you subtract, you add the opposite. And I like it when they have the same sign, because when they have the same sign, what do? We actually add them, okay? So this is going to be 9.1 plus 3.3. 1 plus 3 is 4. Bring down your decimal. 9 plus 3 is 12. So we have 1/5 times, what's it going to be? Negative 12.4. Is that okay? Why was it negative? Because they both share that negative, right? It's like, you're this much in debt and this much in debt, this is your total debt. Now you're like, well, crap, what do we do now? Well, we need to change 1/5 to a decimal, and then we'll multiply the two decimals. Does anybody know what 1/5 is as a decimal? No? Let's do it. And it's a quick